This is number 7. Remember, I think all of these are things you've worked before. Here it says, okay, simplified. It doesn't give much of a hint. Secant beta times tangent beta over cosecant beta. If in doubt, let's try writing everything in terms of sine and cosine. Secant would be 1 over cosine beta. What about tangent? How could I write that? Sine beta over cosine beta. And cosecant would be 1 over sine beta. Well, how the heck do we want to go about simplifying this? I guess the first thing I'll do, I'm going to multiply this stuff on top. We'd have sine beta over cosine beta times cosine beta, cosine square beta. And then this bottom, we still have 1 over sine beta. So what the heck could I do to simplify this some more? Well, if I, multiply by sine beta. Did y'all hear that? If we multiply above and below by sine beta, then this part of the fraction right here is pretty much going to be gone, while there's still a 1. Okay? The 1 over sine beta times sine beta, that leaves us just a 1 on this bottom here, so I won't write that anymore. So I'm looking just at this part right here now. How can that simplify? Well, I guess I could think about sine beta over 1. What would we have? Sine squared beta on top. And what on the bottom? Cosine squared beta, which is tangent squared beta. Oh, can move over. Tangent squared beta. Now, any questions on that? Does this seem like a distant, bad nightmare? Okay.
You got it wrong if you put C.
You
got it wrong if you put C.
Oh my gosh. Well, actually.
One's simplified, so.
Yes. Hey, I wonder about that. I wonder which would it take both of them? A lot of times the instructions would say without a quotient in the answer, which means they didn't want the fraction, but I wonder. Okay, it didn't say anything here on this. Yeah, so I'm thinking it would, I bet it's programmed to take the tangent square beta, not the sine.
Well, it's right, it's not in the simplest form.
Okay, did you hear that? While it's right, it's not in simplest form. Has that ever said that to you, Jerry?
Yeah.
Yeah, oh, okay. Let's see now, the next one, number 8, there won't be any of that because it's not multiple choice. What on earth is this? Okay, so, okay. Number 7. The instructions. The expression simplifies to a constant, a single trig function, only one, or a power of. The reason it's not C, it's not a single trig function, it's 2 trig functions. Okay? I was thinking there's got to be some instruction somewhere trying to say don't choose that one. Now, number 8, same instructions, but it's not multiple choice. Oh wow, what the heck could we do? Well, when I look at this first thing, cosine over sine, do we know a way of writing that? Cotangent. And then plus, no, cosecant x times sine x. Are those reciprocals? something times its reciprocal will always give you what? 1. You can either just put a 1, or if you want to go through and show it. Okay, cosecant is 1 over sine x times sine x. So anything times its reciprocal is going to cancel out and give you just a 1. So we have cotangent squared x plus 1. Does that bring something to mind? A Pythagorean identity? What's the Pythagorean identity that has a 1 and a cotangent in it? Did y'all hear that? Cosecant squared x. So, cosecant squared x. Let's see. Number 9. So use identities to simplify this expression. And I hope that y'all's doesn't regenerate. When y'all pull up yours, they're not exactly the same as these, but they can't change a lot. Okay, that's the downside. Because with trig, they can't just change the numbers like with algebra. Let's see, cotangent squared alpha minus 1 over sine squared alpha. Just because of what we had just done, we had just used 1 plus cotangent squared alpha equals cosecant squared alpha. So I'm sort of thinking maybe it's going to pop, that identity is going to be used again. So what's making me think of that? Well, 1 over sine is what? It's reciprocal of sine. Okay, so we have cotangent squared alpha minus, this minus right here is the one I've carried right there, and the 1 over sine squared alpha is cosecant squared alpha. So can I move this stuff around to figure out an expression for cotangent squared alpha minus cosecant squared alpha? -1, did y'all hear that? We move the 1 over. So this answer here will be easy to type in, -1. Again, why did I put these on here? It just seems the assignment was too short. Any questions? Number 10. Sine pi minus x. I don't just distribute sin and write sine pi minus sine x. Y'all remember what we do? That little pattern. Sine, cosine. It's the same symbol. Cosine, sine. Sine, cosine, cosine, sine. Same symbol in the middle. I'm just, since I don't have a unit circle right here, I'm just going to imagine one. All I'm interested in is pi. That would be 180 degrees. And what's that point of intersection? It would be -1, 0. The first number, the x value, that's the cosine value. The y value, that's the sine value. So we have 0 times cosine x. That's just going to be 0. Then that purple minus. -1. So that minus and negative is going to become a +1 sine x. So this minus and negative, just +1 sine x b. Any questions there? Well, any questions over any of this stuff? Basically, we're sort of finishing up the graphing, and the next time we're going to finally define something we've been using, the inverse trig functions. There are things on your calculator that are labeled sine with a little -1 and cosine with a little -1. It'll show them right here. You may not be able to see them. It's a little -1. Inverse sine, inverse cosine, inverse tangent. We'll define those. And the unit circle is going to make a big return. Okay? So you might find yourself on a unit circle and try to remember these points of intersection. Remember, all of the over 6 ones have the same point of intersection. The only thing that differs is the SIGN sign as you move from quadrants 1, 2, 3, 4. All the over 4, or in other words, all the 5-degree ones have that same square root of 2 over 2, comma square root of 2 over 2. And all the 4 that are closest to the y-axis, or the over 3 ones, the ones that have the 60-degree reference angle, have that same point of intersection, 1/2, comma, square root of 3 over 2. And I didn't want to start that right now. So we will define inverse functions the next time. That's assignment 16. So